Tekrar merhabalar değerli misafirlerimiz. BIM'in önemi Disiplinlerarası Bilgi Paylaşımı Konferansı'nın bu ikinci bölümünde ilk olarak sizlere John McCausland Partners'tan önemli iki konuşmacıyı takdim etmek istiyorum. Hiro Aso, John McCausland Partners'ta Ulaşım ve Altyapı Önemli Projeler Direktörü. Ona eşlik edecek Cliff Green ise yine John McCausland Partners'ta Proje Teknoloji Müdürü. Kendilerini BIM, İlişkiler İnşa Etmek başlıklı sunumlarını sizlerle paylaşmaları adına sahneye davet ediyorum.
Is this working? Yeah. Hello. Give me 1 second to orient myself with the technology. Well, good afternoon. Thank you very much. Thank you to everyone involved in organising this great event, and for giving us the opportunity to talk about our work. It's something we enjoy doing, unfortunately. This presentation will give you a slightly different perspective. There we go. Yeah. Hopefully this presentation will give you a slightly different perspective from the presentations you've had earlier on, and together I think that's very good. It will give a rich kind of diversity of view with regard to BIM. I'm going to start off the presentation by talking a bit about our practice, who we are, what we do, what we think we do, how we organise ourselves, and how we believe that we meet or are organising ourselves to meet the challenges and the opportunities of BIM. We will then illuminate that by looking at 2 case studies in detail. First off, I think it's really important for us to talk about...
Would you please speak louder a bit?
Louder, sorry, yes. Okay. I think it's important to talk about what we think we do as architects. And we are an architectural practice. We're about 110 or 120 strong at the moment. We're based in London. We work across all sectors and at all scales. Although we're a kind of small practice in comparison to many London-based practices, we have kind of quite a big profile, I think. Our work has been awarded over 65 international prizes over the years. We've been voted World Architect of the Year and Architectural Practice of the Year on occasions. And in 2012, one of the projects we're going to be showing was awarded the Bentley BIM'IN Innovation in Building Award for our innovation in the use of project technology. However, our work is guided really by a series of principles, and these we have to foreground every time we work in a project. These principles are to do with the very real complexity we have to deal with in all of our projects, at whatever scale. Very often we're dealing with very complex urban projects with very difficult combinations of culture, of context, and very real formal problems often as well. And we are constantly dealing with this theme of connections, where we build very much in dense urban conditions, in which our projects stand or fall by the quality of the connections we build in them. Consequently, every project we do has to respond to the boundary conditions of that particular project, for that reason, no one project is the same. We don't have a style that you can point to and say is our style. What we think each project has is a kind of if you like, a sensitivity to it that is immediately identifiable as springing from our core principles. This project is the Stanislavski factory in Moscow. It was a creative reinterpretation of an existing heritage building, inserting new uses and new life to the outside as landscape architects as well as architects. It was actually the first project in Russia to be awarded an RIBA award. And I think it kind of illustrates a bit of a recurring theme that we can see in this project as well, which is the Royal Academy of Music in London. This is an intensely delicate site on the edge of Regent's Park in a heritage area where we propose a modern insertion for practice rooms and for other facilities. Again, a kind of meeting of new and old, a building of connections between new and old, and a creation of connections within existing fabric. In some senses, all of our projects we like to think of as transformative in some way, and this project is about as transformative as it gets. This is the refurbishment and reinstatement of the iron market in Haiti after the earthquake in 2010. Again, the reinstatement of a symbolic and a real focus for a kind of an urban existence that had suffered from huge trauma. This building was actually in place and functioning within a year of the earthquake. And on a slightly different scale and of a different order, again, an existing heritage building in London, an unused piece of transport infrastructure, the Roundhouse in Camden, creatively reinterpreted as one of the leading music venues in London. So a place where people come, and a centre for culture where previously it was an abandoned building. And again, the connection between new and old is vital in that reinterpretation or that reimagination. So to work in this way, we need to organise ourselves effectively with our use of project technology. First of all, it's important that we understand that from the very early phase of the project to the end phases, or whichever phase of the project we're involved in, we have to be in the process of maintaining a very strong, persistent flow of design data. Absolutely critical to the importance of this is the fact that at the very early stages, this is as open as possible to as much information as we can port into the project at the early stage as possible. Equally, it's vitally important that we deliver at the point at which we leave the project as much information as we can to support the success of that project in its ongoing phases, whether that's in construction or post completion and occupancy and use. The range of models we do reflects the range of work we do, and one constant we have to do is always we have to represent this visually in an engaging way. To do that, we have to use the various data sources we have in as efficient a way as possible. We have to be able to interface with other modes of representation of the project, whether that's rendering or whether that's the more conventional sort of BIM representations you've got here. Or actually it may be the fact that we're working across multiple modes of production. So maybe not just BIM, or not just a generic BIM process, but a kind of mix of 2D, 3D and BIM. And we have to accept that. We work in a very messy way, actually. We sketch, we throw things away, we reinterpret things, we we draw constantly, and our method of working has to accommodate that, and we have to enable ourselves to do this kind of stuff whilst maintaining this flow of data. Okay, so I think that's a kind of a key motif of the way we organise ourselves. As importantly, though, and interestingly, the previous speaker was talking about computational design and the continuities or otherwise with the generic idea of BIM, is that this process has to enable us to capture as many of those sources of information and approaches and attitudes to information to enable us to fully develop our work. Okay, so this kind of thing, which you'll see later on, I think people will recognize as a BIM model. It's fully coordinated in the sense it has data attached to it. And it's a very powerful method for delivering a project. However, we have to, as architects, get to grips with and understand organising our data in structured ways, perhaps in ways that come from other domains. Okay, so for instance, parametric studies for complex curvatures, and you'll see this in the project we talk about later. And these two sort of little snapshots are examples of exactly this kind of thing. In this case, a neural network, an artificial neural network, to address a specifically architectural problem of form finding, and a genetic algorithm which is addressing, again, a specifically architectural problem to drive optimization in relation to a townscape and visibility analysis. Both of these bits of work designed, coded, and implemented by architects in practice. One last word about the process, I think, is that we mentioned that we use MicroStation, and our host Bentley, who have invited us to come here, we have a long association with them because we use their software. We use it because it supports everything I've been talking about. It supports the fact that we can work in multi-modes. It supports the openness at the beginning and end of each model. It supports the fact that we can disaggregate data across very complex projects if necessary. And in that sense, it reflects real life. You know, real life can't be encapsulated in one fully coherent model, and any fully coherent model that doesn't relate to real life in some way is not of value to us. I'm going to illuminate some of those sort of rather abstract ideas with looking at two case studies. Both of them are actually literal examples of connections. They are both high-profile, massive infrastructure projects in London, at the heart of a world city. Their client base, if you can call them that, the people who use these projects, is not a small, isolated group of individuals or an organisation. The numbers of the clients for these projects runs into tens of millions, actually. So we can really say these are world sort of projects. We're going to talk through these, and we're going to illuminate some of the project technology and BIM aspects of them as we talk through them. So I'm going to hand over to Hero now to take over at this stage of the presentation.
Okay, hello, merhaba. That's all I know. Okay, I have to admit, I'm a simple architect. He's the BIM expert. Cliff is also an architect, but he's managed to really articulate the importance of technology and BIM within our practice. I sort of pretend to understand, I don't. So maybe I can reach out to those people in the audience who are still with me at my stage, who are trying to understand what is BIM, what is a BIM in the process of design. Actually, for me, BIM should be DIM. It should be design integrated model, but DIM doesn't sound very good. So I understand. BIM is the word, but I want to sort of give you a bit of a narration from a simple architect's perspective. Some of the slides refer to a project that has been mentioned by Hassan. It's a big infrastructure project, and I want to say this. I have a real anxiety about BIM. I have equal measures, expectation, and anxiety and worry. And if I can explain that with an analogy with emails. I've been in my practice. I'm a director of John McCaslin Partners. I've been there for 19 odd years, and I saw email being introduced into our practice. My anxiety, if I can do the negative first, my anxiety is that BIM doesn't go into a world of emails where it actually truncates communication. It stops people from talking to each other because there's this kind of ethereal thing that somehow magically glues all of us together. And I'm really worried about that because you know, I know, we all do it. We send an email and we don't really think about the impact of that, but we think we're doing communication. Actually, sometimes it's not very good communication. The expectation I have for BIM is that it should really somehow charge us to do better design and better building, better delivery of buildings. So I'm sort of on the fence. I don't know which way it's going to go, and maybe you are much brighter than I am, and you can see exactly where BIM's going. But maybe I can share my anxiety with you, and those of you who will be in the control seat, in the driving seat of defining BIM for the future, you can make sure that it's not going to end up where, for me, email has sort of dropped into this kind of nasty place where I think it's underutilized and badly utilized. Anyway, so here on this project called Crossrail, we had a really integrated, and we are still working to an integrated information system model. We are working in different teams. My team, I'm the lead architect for Bond Street Station in the middle of Westminster. In Mayfair, and I'm working alongside a team that's working on Tottenham Court Road Station just next door on one side, Paddington Station another side. We're all working separately but all essentially uploading and essentially connected to the central service system. But you know what? The thing that I really enjoy is when we pin up work still manually and we say, like, this is what we've done. What do you think, engineer X? What do you think, designer Y? And we have a sort of a live communication with printed matter. So this is where my anxiety is, because I do know that the clash detection issues, which is highly important, the ability to predict what might happen during the construction stage is all vitally critical stuff. But how does that relate to our behavior during the design development stages? I don't know. I've yet to see BIM really sort of go in there and challenge each one of us to be able to fulfill our obligations as designers early on in the design process. That's not to say we haven't used CAD, we haven't used technology. Of course we have. But in terms of philosophical debate about BIM and the discussions around technology, I leave that thought with you. I mean, just incidentally, hands up if you're an engineer. If I may ask, hands up, okay. Hands up if you're an architect. Hey, excellent. So I shouldn't be too scared then. How many of you are clients who are sort of commissioning projects? None. Excellent, we can be rude about them. And how many of you are contractors who are, you know, in the responsibility to deliver? One sole person over there, 2, 3. Right. You see, the point is we should all be talking to each other, and this is what I'm hoping BIM will actually facilitate, and it's not actually going to separate us further. Anyway, enough of that. So, as architects, we develop and we share ideas about our particular concerns. These are to do with movement. I mean, my responsibility is transportation and infrastructure design. So, it's all about movement. Movement of people, movements of vehicles, making sure that we don't clog up. This is Oxford Street, arguably one of the most recognizable retail destinations around the world. And we're making a huge impact. And actually, some regard it as very negative. I think it's great. I tell my wife never to go shopping in that area because it's really difficult to walk around. So I can control the finances in my domestic situation. But I mean, it's a serious obligation to make sure that we keep not only the traffic moving, of course, during construction, but when it's all finished, we don't sort of surcharge movement onto this part of very dense city and make sure that things don't collapse. heritage. We have to respond to particular heritage context. Of course, as you, we have some amazing heritage situations. And I wonder how BIM fits into this, at this kind of level of macro scrutiny. I don't know yet. I don't know yet. But alas, it allows us to give an overview once some commitments are made during the design development stages. This is a bit of a cartoon illustration mapping. Actually, it's a real 3D model that we've been developing with Crossrail. The location of the station. It's a super long station, 300 meters long. This is the longest metro that London has ever really considered. So long that we have two big station structures popping up in the east near Hanover Square here, and to the west next to the existing Bond Street station. Major pieces of civil engineering. General arrangement, section at the top, West Station, East Station, diving down by escalators to these really long platforms. And yes, all of that is, of course, fully coordinated thanks to the technology that we have the ability to use. I think we initially started on Triformer. I don't know what it is technically called now. I'm an idiot. Forgive me. I believe it's the Bentley system that we are still plugged into. As Cliff mentioned, I think it's right. Architecture and engineering design can be messy, should be tactile. And again, that's where I'm really interested to see where BIM is going to take us, because we love models, we love sketches, we love messy things. And somehow in my mind, I see BIM as a really kind of clean and almost sort of sanitized world, a version of the world. And I just wonder how that's going to provoke and challenge and take our design world into the next stage. So at Crossrail, there were issues about external obligations in terms of how the building sat within the context. You can see there's a sort of interesting visual. Day one, just a station with a huge chimney. Day two, in the future, we have an overstation development landing on top, and so all the interface issues are fairly important to get right. And again, the BIM model allowed us to predict what happens when we're building this on day one, and all the impacts on the surrounding movement of people and traffic, but also what might happen in the future when we surcharge the pavilion, what we've termed, what I've called the colonnaded pavilion structure with a 6-story building on top. Again, it's all simulated and computational wizardry that I really wouldn't pretend to know how it all works, but it's been all assessed, and again, that's something that we probably couldn't have done to the sophistication and accuracy. I think probably the accuracy is the important point here, maybe perhaps 10-15 years ago. So we have a red station in the west, a green, white building, a white station on the east. Looking at the situation when it's all finished, so we want to make sure that we don't cause problems with additional traffic that's unplanned or unallowed for. And I suppose this is where I might start to hand back to you, Cliff. This is where I guess the thinking have turned into commitments of what the general arrangement looks like in the BIM world.
I hope this doesn't sound a bit too much like a schizophrenic presentation. Much to Hero's disgust, underlying all the work that we do, all that kind of detailed work we need to do in our architectural enterprise, sits what is probably, I would say, the biggest BIM model in existence, actually, and this is only a very small part of it. As I mentioned, what I believe is a kind of enterprise level collaboration between Bentley and Crossrail to deliver the whole project in Bentley architecture, in BIM. So that's using the full suite of Bentley products sitting on top of the MicroStation platform. And here's our bit of it. There are literally thousands of models in this BIM model, so this is a big BIM model disaggregated into thousands of separate models, which again makes sense. It's a really smart way to work. We can re-aggregate models as and when we need them to work on them, and that's precisely what we do. So for our element, we use the models we don't need to repurpose data. We can use it in our workflow for that kind of detail level of work that Hiro was talking about. And we can routinely use it to leverage this kind of design verification work, actually, which is looking at spatial sequence of the narrative of the building and so on.
Can I just one more thing?
Yeah.
Sorry. Just to go back to this slide, I just want to mention, I mean, where BIM really excels is when we're trying to do something like this. This is what I called nowhere to hide architecture. If you look up, you see things which are exposed, and there's a confidence in expressing ventilation, structure, primary, secondary, tertiary, fittings, all sorts. And that's one approach. What we decided to do here is essentially hide all the conduits. There's nowhere to hide, so you've got to get all the conduits, cable management, everything sorted out before we go to site. I'm not saying this is, this is an amazing space and it's got this amazing quality to it, but we're trying to do something where I guess, again, we really would have had trouble doing it if it wasn't for the CAD and the IT technology, equipment and tools that we have. Sorry.
So having the model and having the data, without repurposing that data, it's persistent data, we can use it to run all kinds of simulations. These are pedestrian simulations done using Legion software, but using the same source data set from our model. So a constant series of design validation checks, if you like. We can represent the model to give confidence to all parties involved in the process with regard to all kinds of issues, in this case buildability or sequencing, and the ability for us to give very strong expression to this is absolutely critical to our work. So that's why you're seeing a lot of these visualizations. They're not they're actually really important, actually, and they're important in our work, and we use them all the time. Anyway, just another kind of sequence of series of images showing the level of granularity that this model can go down to, really, for not just coordination, but for the ensuring provision of a design that works. And that level of detail is, a kind of aspect of BIM that we take for granted. That looks like a BIM model. Sitting on top of this and working alongside it is our multimodal work that is equally as important to the project. And with that, we'll move on to the next case study. So Hiro's back again.
All right. So as a contrast, King's Cross, and again, delighted to have been selected for a prize in last year's Be Inspired event. I remember we had a really fascinating discussion about the use of, again, BIM for a heritage building or an existing building. I think the general sort of the feel that we all have is that if it's a sort of completely new build building, it's kind of easier to do a sort of a full-scale CAD model than and sort of meaningful. But we get sort of confused. We have uncertainties about doing something for an existing historic building. Why would you want to make a full model of an existing building? Well, I hope through these sequence of slides, perhaps I can sort of share with you certainly how we managed to work off the immense capability and resource that BIM represents. So this is a historic building, quite a contrast to Bond Street. That's a spanking new building that'll be finished in 7 years' time. This dates back to 1852. If you can just remember the clock tower here, just to sort of, it's a very useful orientational device when we fly around the building in a moment. And it has all sorts of, I guess, built-in beauty about it. So really, in terms of the historic fabric, how we worked with that, it was about integrating additional necessary structure for either reinforcement, to take on additional loading capacities, and also integration of services. I had where's Isam? Isam's gone. I had an interesting discussion with Isam about the challenges often we face about the live connection between all the disciplines, because we don't talk to each other, we just fire emails to each other. That's the problem. We should be talking to each other a bit more. Where we sometimes lack the foresight of how services integrate into existing buildings. The heart of this project was really cleansing this historic building that had accrued all sorts of rubbish over 150 odd years. So it was peeling away rubbish. But at the same time, trying to find new ways of putting in infrastructure, both at the micro scale, how do you put PAVAs, passenger announcements, and speaker systems, and CCTV cameras, and so forth, at the micro level, but also the macro level. How do you make a piece of London, which actually before we came on board looked and felt as they look quite grubby, quite scary. I'm not going to embarrass myself to say to you that when we were competing, we had to compete in 1997 for this project. I was walking down the street with a camera, and I got chased by two what we call ladies of the night with baseball bats, and I just had to say, "Oh, leave me alone! I'm just taking photos. Forgive me." Really kind of rather nasty spaces. Of course, now completely transformed. It's where what we call sort of grade A tenants and businesses wish to come to, and actually they've come to enjoy the heritage, and how heritage has been given another lease of life for another 150 years. At the heart of it, though, just to sort of go back to the movement issue, of course we have to integrate this station into a modern transport hub. We have 5 underground lines coming into this station, and certainly around the vicinity of the station, as well as St Pancras station adjacent, which if you've been to London, you'll know this is where the Eurostar, the international line, comes into London. So this is also has an international dimension. Some statistics. So it's a big project. It's a big project, and it's a huge investment. It was, I think, on the brochure, something like 547 million pounds. What's that? That's probably about $800 million. That's a stupid amount of money in many regards. And so we've got to make sure we make the investment work really hard. And that's both internal, making sure that the space is wonderful and encourages more patronage, more usage, but also external. So we are essentially recharging this part of forgotten London into somewhere that businesses want to come. You want to come to. You want to bring your family to it as well. So this is a sort of helpful orientational drawing. So clock tower now back here. So we're flying to the north of the train shed, cutting a section. The project doesn't look like this. We've cut a section through it. I'm explaining that for contractors who can't read our drawing sometimes. So we have the double-barrel historic train shed. That was a joke. And we have, of course, the new concourse structure to the west. Building grade 1 listed, built by a very important Victorian engineer architect, Lewis Cubitt, who also designed this building, the Great Northern Hotel. This is a very typical topology of main terminal stations in London. You have a big railway station and an associated hotel structure. Here, so you can see that essentially the project is about sort of 2 halves, working with this amazing and a beautifully clear Victorian piece of engineering and construction, and a new building. Well, I think people sort of consider that to be the sort of sexy bit. I might not say that this is the kind of the cool bit, but actually where my heart is actually in working with the historic building. So another section through. That's the cross section. Cutting through Western Concourse building. This is important, the London Underground box underneath, which is also shown transversely, cutting across north-south here. So that's a new concourse structure with the London Underground box underneath. Maybe at this point I'll explain, because some people have asked before, what gave rise to this kind of this amazing-looking structure? Well, it all down to the interface, and it's an interface that actually BIM couldn't help us resolve. When we started back in 1997, we had all the parties and stakeholders aligned, and we were charging ahead, really happy. We were all sort of going through the honeymoon period. And our client, which was called Railtrack at that stage, went into administration. It went bust, and down went our project with it. our hearts sank, but actually we were too elate. We found out that the organization would come back as Network Rail, it's a current client, with the ambition to actually realize the vision that we had worked up with Railtrack. So amazing. This you know, a moment of amazement. However, we found out that in the intervening period, I can't remember, sort of 6-9 months, something like that, the alignment that we had with the tube, the underground metro tube down here, had been essentially misaligned quite monumentally. And we had two choices basically. One, to essentially tell them to change their bin model, you know, tell them to change their blueprint, because what was happening here was that basically they were essentially starting to procure, that's the kind of the Network Rail term for, so building this box, which meant that we can only position columns for this rather, for a large concourse space in certain locations that we didn't want. I mean, as transport architect, I say barriers are our enemy. We hate barriers. And what this led would have been a need to essentially bring down columns in locations that we didn't want. So option number two was essentially to avoid the problem. So just jump over the problem. So what this is about essentially that engineering architectural design challenge, to jump over the London Underground box, which is down here. So we found a way of essentially landing a huge structure. It's some 7,000 square meters, spans about 100 and, I think it was overstated in the catalog somewhere. It's about 140 meters across. It rises to about 90 meters high, and at the widest point it's about 66 meters. So it's a huge space, jumping over and essentially avoiding completely this construction that was being progressed by London Underground, hence the reason. And you know, that's where we really enjoy the challenge of expressing engineering architecture, where you can't really tell where it starts and where it ends. And actually, if I'm completely honest, it was a completely collaborative process. So we were talking to each other, you see. We were talking, engineers and architects talking to each other. So going back to the historic bit, this is about sort of peeling away, cleansing and tidying the historic building. And again, I guess in some regards, limited use in terms of BIM. However, there were instances where we essentially had to find ways to put CCTV, PAVA. And we did that by essentially doing a model of the existing building, the historic building, and finding ways discreetly and minimizing the need for repair and additional works to essentially conceal, where possible, unwanted conduits. So cable management was a very key part of the design process, which we did with BIM technology. Here, it's another fairly simple CAD model that we built of the historic train shed at a key moment where we are introducing a new bridge with escalator links down, passenger lift, and a lift for onboard services, OBS. This is where the trains get charged with teas, biscuits, and sandwiches, and so forth. So again, we were using computer technology, CAD, and 3D modeling across the entire field, not just in the sort of the new sexy bit. And it came into the sort of simulation of remodeled Victorian building came really useful in situations like this. I mean, this is what's called the gate line. This is where we delineate what's paid side. This is where people have tickets, and unpaid side where people don't have tickets. So very, very important threshold. This was created within essentially a 30-meter zone within the Victorian brick building. Now, if you know anything about Victorian buildings are load-bearing brick buildings, and they're building of walls. So to create this big open span space by introducing this tremendous new structure, we had to get it right. And again, this is underneath 3 stories of Grade 1 listed National Monument Heritage structure. So the settling and the movement issues were absolutely hypersensitive, uber sensitive. And again, that was controlled by making sure that we had full use of BIM modeling. In here, what looks like a very simple space, this is a historic booking hall, represented as a booking hall, has actually in each of these bays major steel columns RHSs going through here to essentially take the load of additional loading from up above. And again, we did that just understanding what the implications were on existing foundations. And again, so, we therefore relied on perhaps localized modeling, but modeling nevertheless within an existing building. This is an important space used to handle postage and letters and parcels, therefore called the parcels atrium. And we decided we want to open this up into a restaurant, and to do that without sticking it full of, again, conduits and additional structure, which was required, unfortunately. We found that the floors were unstable and failing, so we had to try and introduce additional stiffness. And we could, again, visually control that, not just physically control it, by creating, you can see the model over here. But going back to movement, it's all about movement. It's all about movement. What this does is two things. One, it creates a sort of an underlay for a guy like me. I read Legion models plans, and I can say to you, this is how a station or a shopping center should look, and this is what I do, this is what I enjoy. So we can get that the flow of people through space absolutely spot on. But also, of course, now we're realizing that understanding movement is absolutely key to realize a very important agenda that clients like Network Rail or Istanbul Metro Authority will have, which is trying to create revenue from us, from their investments. So basically, retail facilities. And if you don't get that right, you could be missing a huge opportunity to create a win-win situation. A win for passengers to find really good, convenient, high-value retail, and a win for the operator owner to essentially gain revenue and financial income from that investment. Do I pass this over to you? So we continue with our modeling work, and this is where we were essentially at probably that schematic stage testing the performance of the design by essentially seeing how these dots are all people would be we hope will behave within the space. So we ran many models to make sure that this is, I think, Legion based, to make sure that we had the movement properly assessed, and actually the outcome of that design provided a perfectly functioning and, importantly, pleasant space for passengers to experience. And this went down not just within the limited into the concourse area, but also associated underground passageways. I should have mentioned King's Cross Station handles about 15 million passengers per annum. That's about a peak 150,000 passengers a day, and 60% of that is interchanging with different modes, particularly with London Underground. So this is the diagram here down below shows the movement generated by the mainline station, our station at King's Cross, into the metro station down below. And we continue this with the macro analysis.
Yeah, I mean, one of the interesting things in terms of coming back to the idea of connecting this persistent data flow through the project is that we can carry out this modeling and validation exercises during the design phase of the project. But we kind of very often leave buildings alone when we finish our active involvement in them. And we've been very fortunate enough to actually continue our involvement in a different register with this project, in an attempt to kind of create that connection of data, if you like, beyond the further into the project cycle. This is a collaboration that we carried out with University College London, looking at space syntax analysis of the project. So understanding architectural configuration, how it relates to natural human movement through spaces, combined with actually observing how people use the station. And remember, the station is now open and it's being used. It's a very gratifying experience to go in the building and see it being used actually in ways that you kind of imagined it would be. But we can measure that, we can plot it, we can use GIS technologies here to carry out, again, in another techniques from a different domain of architecture, using statistical spatial analysis to understand what's happening in the project. And again, these studies carried out by architects. These kind of correlation diagrams are produced by architects to understand the correlation between the theoretical model and reality. the sexy bit of the building, Heroes mentioned, which gets everyone's immediate attention, was, and he's alluded to that idea, it's kind of an almost seamless junction of architecture and engineering. So where does one start and the other finish? And actually they don't, they just meld together completely. From the earliest phases of the project, architects and engineers at Arup, who were the engineers, the structural engineers on the project, were working collaboratively, seamlessly together, producing a geometry statement to define the basic organizing principles of the roof, working in a range of softwares actually, Bentley, MicroStation, and structural analysis software developed bespoke by Arup for this purpose, to analyze structurally the performance of the evolving design. And that design couldn't have been achieved without that very close collaboration at that stage between architect and engineer. Similarly, in a different discipline, the lighting of the roof, which is a key component of the design, was intensively modeled using the same data, so this is not repurposed or redrawn. This is the same wireframe models we're using to analyze for lighting conditions for the artificial lighting design. The actual geometry, if you like, from the coordinated design was then passed through the project from early concept modeling through to diagrammatic drawings, through to analyses of the structure, finite element analysis, and then that same data was passed on to the contractor and fabricators, and they, particularly in the casting of these nodes, actually used the 3D data direct. Okay, and here it is. Here's the result. It's kind of, I would say, emphatically a delight, but not in an overtly technological sense, if that makes sense. We appreciate this for the beauty of the space it creates, in ways that we can attempt to build into our process and express in our BIM model. If we try hard enough, we think we can achieve some pretty good results. This kind of project, I think, represents where we are with that attempt to build a connection between BIM and beauty, I guess. So thank you.
Thank you. Çok teşekkürler. Thank you very much. Would you like to send maybe if there are any questions to our guests? Well, there's just one behind.
Sarp Sabuncu. I couldn't able to understand directly how the revenue after how you are getting the revenues. You have been talking during the operation period of a metro station or something, you can increase the revenue, and how you can solve this one with BIM. I couldn't able to understand that part. On one slide you have been discussing about during the operation we can analyze that, and can you, maybe I couldn't able to understand also, that's why I'm lost a little bit.
Okay. Can you hear me? Okay. So I think, forgive me, I think you might be referring to what we said about the use of computational modeling, CAD modeling, on the performance of space during design and then after design. Is that the bit that you want me to explain a little bit more about?
Indeed, that's why I'm lost a little bit, so I couldn't able to say what is it, but there was a slide that's showing diagram with arrows, like...
right. Can I go back?
Sure.
No, it's gone. So I think it's the diagram, it's the slide with lots of little diagrams with arrows everywhere. Yeah, that diagram was about understanding the movement of people through through the station. So it's a multi-service station. It's a multi-passenger profile station. So by that I mean it serves commuters, people going to work. It serves long-distance travelers who may be going to work or who may be traveling on holiday, for example. First-time travelers who need to probably be given space to understand which way they need to go. Mixture of passengers using mixture of lines, intercity, short-haul, regional, international, lots of different passengers. So what we mapped out was essentially the potential movement, potential movement of those passengers. So here, this is about the arrivals from essentially what we call suburban trains. These are commuter services, servicing a sort of an intermediate region like Cambridge. It's an area you may or may not be aware. Actually, they generate the biggest passenger pressure within the station because a lot of commuters live in that region, St Albans, Cambridge, in that direction. So we had to make sure that we had the flows understood, which essentially generate widths of space, volume of space that we need to allow for, and which way they go. How many of those people go into the underground? How many go into other lines? How many go into the street to pick up taxis? How many people go to buses? How many just walk to their destination? So that's what this sort of illustration is summarizing. It's a very simplified version. And here it's about the people arriving on the long haul train. So these are from long distance, Scotland, further up north of England, coming in. And again, then where do they go? And what percentage of people go into the metro, buses, taxi, etc., etc. And we run this for all the permutations. It might be, so we know where a person might be, a student might be arriving to go to a nearby college, so we can map what that route might be and the intensity of usage of that route. So these are the things that inform the basis of a layout, which was all about people movement and where people need to stand, where people need to move, where people need to check their directions, check their tickets. So that this formed the foundation for the blueprint for the station. Okay.
One final, please, and you'll go. Don't worry.
Thank you for the presentation. My name is Fatma. I am an architect. Which kind of communication or non-communication problem did you encounter? At which level with the client or between the team? Although you are using BIM and emails, and how did you prevent or solve those non-communication problems about, of course, the project?
Okay.
Thanks.
If I may answer that this way, the project started in 1997. Really got going in 1998. Now, if you remember back what it was like in the world of IT and CAD in 1998, you can sort of guess that it wasn't as energetic as it is now. So we essentially introduced BIM, as we understand it now, into the project during the course of the 16 years that we've been working on this. 9 years of that has been in design, and sort of 4, 5, 6 years of that on site. And we're just opening, actually today, opening the final piece, which is the square in the front. So there's a sort of a big ceremony today with the Mayor of London opening that. But I prefer to be here in Istanbul. Come on, it's 28 degrees outside. No brainer, no obvious choice. To essentially mark the completion of the project. So it's a long period of time. So I guess it isn't a clean BIM exemplar where we had the ability to use BIM across the entire project and brought it together. Actually, sort of appeared here, then appeared there. Then we eventually slowly pulled it together during the final stages of implementation, construction, delivery. So, how did therefore BIM help the conversations? Well, I suppose really it helped during the latter stages of the project because it was only available then. At the beginning, we relied on manual drawings and the other techniques that we have used, in the mid-90s. So, I suppose it gives confidence to stakeholders. Stakeholders range from clients to people who are interested in the project, sponsors, that there is a committed and coordinated endeavor if you can demonstrate and show them that there is evidence of the things coming together. So I think for me, I think it generated confidence. Whether it solved the lack of communication between individual teams, I don't know, because ultimately if we have to rely on technology to help us communicate, I think there's really fundamentally something wrong with all of us. We should be talking because we need to, because we want to, and it shouldn't be because there's a technology available to do that. So, I don't know, maybe I'm sort of going off piste again, but certainly we enjoyed and benefited from BIM, but unlike Crossrail, where we started really from the word go, King's Cross, it kind of happened in a slightly undesigned way to get to the product that we've shown you. Thank you. Okay. Great. Thank you.
Hiro ve Cliff Green'e çok teşekkür ediyoruz. Hiro maalesef hemen uçağa yetişmesi gerekiyor. O yüzden Cliff konferans bitiminde burada olacak. Dolayısıyla sorularınız varsa kendisiyle tabii ki buluşabileceksiniz. Ve son olarak konferansın son konuşmacısı